Hi, in this video we're going to talk a little bit about Holt-Winter's forecasting model, and it builds upon the moving average that we discussed in the previous video. In the previous video we talked about simple exponential smoothing, and one of the limitations of simple exponential smoothing is that it does not perform well with data that has some sort of trend or some sort of seasonality. And by trend I mean something that looks like maybe the data goes up and there's an upward trend like this, or if there's a seasonal cycle. So you might see something like at a regular period, maybe around the holiday season, there's an increase in sales, and then an increase in sales like at Christmas time or something like that, or bathing suits in the springtime as people are getting ready for the summer, or ski equipment before the winter, things like that. So those are seasonal cycles that we might see. So Holt's exponential smoothing is used for data with trends. So we're going to look at that in a minute. And then the next type of modeling is Holt-Winter's exponential smoothing, which takes the trend and then adds another component to the model for seasonality. So before we begin, let's look at some data. This is international airline passengers in thousands from the years 49 to 1960. You can see going down the left-hand side of the screen is the year, and then months going across. If this were a time series data, you would look at this row first of 1949 and then wrap around to 1950, et cetera, et cetera. Here is the graph of the data. And one of the first things you want to do when you do get some data is to graph it and make some visualizations. We can see here some interesting observations. Just by eyeballing it, there does look like there is some sort of trend. It's an upward trend. So as we go into the future, more and more people are riding the airplanes, the international passengers. The other thing I notice is that there seems to be some sort of cycle here, right? You can sort of see this up and down, and it seems to be at regular intervals. So if we look at here, it seems to be just before at the end of the year. So in the end of the year 1950, in the the third or fourth quarter, there's an increase, a spike, maybe around the holiday season. And we seem to see that toward the third quarter of as we go through time. So there does seem to be some sort of seasonal cycle. So let's look at the Holt-Winter's model. But before we do, let's take a look at the equations. These are the equations that I introduced in the moving average section for simple exponential smoothing. And recall our prediction for the next time period, t plus 1, is some sort of combination of today's value, yt, and our previous estimate of t minus 1. And recall that alpha is between 0 and 1. So if alpha is 60.6, 60%, you multiply, takes 60% of your weight from yt, and 1 minus 60, or 0.4 of yt minus 1. Notice the subscripts go from t from 1 to capital T. So this first equation is for the immediate future, 1 period forward. And this is the prediction given the past data of any value of t. Now before I go into the equations for the Holt-Winter's model, I want to I want to rephrase the simple exponential smoothing into component forms. And basically, here's your y, t plus h, and I'm just going to call it LT, and LT is this, the level equation, and that's the equation we saw before, right? So if you compare the last slide, you see yt plus h equals alpha yt plus 1 minus alpha, like this. And in this case, we're just breaking it up into two pieces. L is for the level occasion, or the smooth value, and h is the lag. So if h equals 1, it gives the fitted value for 1 period difference, but we can look multiple periods in the future. You might ask why we're bothering to put the equation in this form and separating it into two equations. And right now, quite frankly, it's not very useful because there's this simple substitution here, and I could just say yt plus h, this is equal to this, and not bother with that L sub t notation. But as we go forward, it becomes very, very useful. So let's leave it at that for the moment. And here's where we see y. So this is the linear trend model. And recall in this model, we're looking for some sort of trend. And we're going to add some sort of trend in there. So here is the forecast, t plus h periods ahead. And there's the level equation. And we see that there really is no difference in the level equation. It's the exact same level equation that we saw before. And the difference here that I want you to focus on is this term here, h bt. Okay? So if h is 1, that means just look one forward and one period into the future. But if there's multiple periods in the future, we want to look at 1 period, 2 period in the future, 3 periods in the future. So bt is some sort of trend equation. So am I looking at 1 period in the trend, 2 periods in the trend, et cetera, et cetera. So h is the number of periods looking forward, and I multiply it by this bt, which helps describe what the trend is. And this trend is nothing more than a weighted average of the prior trends. So if you look at it, here's the trend equation. And here again, we see that pattern of beta and 1 minus beta, right? So again, beta has to be between 0 and 1, okay? And what are we weighting here? Well, on this side of the equation, we're going to weight our past estimate of our trend. And here, we're taking the difference between the level of equation of today and the level equation of yesterday. And so if it goes up, we can sort of see a trend. If it goes down, this will be negative, and we can see a trend. And that will be our weighted average of the trend.